So guys, welcome back. This section of the course is dedicated to learning 4 stages of the compilation of a program. This is a very pet interview question and one of the most commonly asked questions. So let us see in detail that what are the 4 stages that are involved in the compilation process of a program. So you can see on the screen the 4 stages which are involved in the complete compilation of a process from beginning to end is the pre-processing stage, then compilation stage, followed by the assembler stage, and then last stage of the compilation process is the linking stage. So let us first discuss each of these stages briefly. Then I will show you the demonstration how a given program can be compiled stage by stage, and we will see that what are the changes in the program takes place as the program compiles through these stages. So the very first stage of the compilation process is the pre-processing stage. The program that you write by your own hand in an editor is an input to the pre-processing stage. So in pre-processing stage, mainly the text substitution is done and the pre-processing directives are executed. Now what are pre-processing directives? All the statements in your C program which starts with the hash are called pre-processing directives. For example, hash include, hash define, hash if define, etc. We have already discussed the text substitution in pretty much detail in the beginning section of this course. Then once the pre-processing of the program is done, the resultant program is actually fed to another component of the compiler, which is actually called compiler. So note that technically speaking, the compilation process is the second stage of a compilation process. In our day-to-day life, we usually call all these 4 stages collectively as compilation. But technically speaking, the compilation is actually the second stage of compilation process. So you can see that to the compilation process, the input is the text substituted C code and the compiler generates an assembly code as an output. So assembly is a programming language and it is the compiler which takes an input, the text substituted C code, and in turn it generates an assembly code, right? This assembly code is equivalent in functionality to the text substituted C code which was fed to this compiler. Then this assembly code which is generated by compiler is then fed to the third component of the compiler called assembler. So assembler is that component of the compiler which takes an input, the assembly code, and produces the machine code or binary code. Now once you have a compiled codes means your .o files, that is object files. If there are more than one object files, then all of these object files can be grouped together in order to form a library, right? We have already learned that library is nothing but it is a collection of object files. And what are object files? Object files are nothing but they are compiled machine code or binary code which is produced by the assembler. And the second option is that if you do not want to reduce your program into a library, then you may subject your program to the linking process and finally produce an executable. But your program can be subjected to the linking process only under one condition, that your program must have a main function. Unless your program do not have a main function, it cannot be subjected to linking. So linking is a process of creating an executable from the compiled machine code or object files. Now you must have understood why I am calling executable. Executable is a program which is compiled already and can execute on a processor. And we know that for a program to execute on a processor, the program should have a main function, right? So linking is a process of translating the object files or the group of object files together to form a final executable which can execute on your processor. So note that the preprocessor, the compiler, assembler and linker are generally together termed as compiler only, right? So these are the four stages of the compilation process, beginning from the pre-processing stage up to the linking stage, and you should remember the sequence of these stages. Not only that, for each stage you should remember that what is the input to that stage and what that particular stage produces an output. So remember these kind of a flow chart, and remember that if you want to create a library is nothing but it is a bunch of object files put together, right? And in order to create a library, your program do not have to go through the linking process. But in order to create a final executable, your program has to go through the linking process. Now next we will take a sample program and we will subject that program step by step through each of these four stages of the compilation process and actually see the things in action.